Hello everyone and welcome to the next session of the subject Electronic Engineering Materials. In this session, we are going to discuss the third unit of the subject Electronic Engineering Materials. In that one, the third unit is Magnetic Properties of Material. Now, this unit is having 10 hours of lectures and having the 16 marks. So let's start. This is the syllabus for unit number 3. Unit name is Magnetic Properties of Material. This unit is having 4 outcomes. Means after the completion of this unit, the student should be able to identify the magnetic materials on the basis of given magnetic properties. Next unit outcome is describe the given hysteresis loop identifying the material. Unit outcome number 3, that is 3C, describe the effect on permeability of the material due to the given factors. And unit outcome number 4, that is 3D, explain the concept of anti-ferromagnetism. Now, this unit is distributed in 5 main topics, such as topic number 1, that is nothing but classification of magnetic materials, permanent magnetic dipole, diamagnetism concept, paramagnetism concept, ferromagnetism concept, and ferromagnetic domain. Next topic is magnetization curve, hysteresis loop, magnetostriction effect, application for the ultrasonic generation, permeability and affecting factors. Next topic is nothing but magnetic materials, iron and the silicon iron alloy, nickel iron alloy. The last topic is nothing but antiferromagnetism and ferromagnetism concept. Now let's start to discuss unit number 3 with the basic concept. Now in the introductory part, we are going to discuss the concept of magnetism. Magnetism is a phenomenon by which a material exerts either attractive or a repulsive force on another. Basic source of magnetic force is movement of electrically charged particles. Thus, the magnetic behavior of a material can be traced to the structure of atoms. Electrons in atoms have a planetary motion in that they go around the nucleus. This orbital motion and its own spin cause separate magnetic moments which contributes to the magnetic behavior of materials. Thus, every material can respond to a magnetic field. However, the manner in which a material responds depends on much on its atomic structure and determines whether a material will be strongly or weakly magnetic. Now we can start the definition of the magnetic materials. The materials in which a state of magnetism can be induced is called as magnetic materials. Now, the magnetism is a phenomenon by which the material exerts two types of forces in that material. Either the force is having the attractive type or it should be having the repulsive force type. The main concept behind this magnetism is that the magnetic force movement is an electrically charged particles which behavior of that material should be depends upon the structure of an atom. Now, the electrons in an atom have a planetary motion in the orbit that they go around the nucleus. Now, this orbital motion and its own spin, because every electrons which are moving around the nucleus also it have its own spin around itself, causes to a separate magnetic moments which contributes to the magnetic behavior of materials, and thus every material can respond to a magnetic field. Now, however, the manner in which a material responds depends upon much on its atomic structure, and it should be determines whether a material will be a strongly magnetic or it should be weakly magnetic. Now, the same concept we have again discussed with the help of diagram. Okay, what are magnet and magnetism? Now over here, one magnetic material or one magnet, it should be indicates two types of poles, that is north indicated by capital N and south indicated by capital S. Now, as the magnetic field is produced along with this magnet is indicated with curved lines called as magnetic flux lines with the indication of arrow. Now, the magnetic flux lines are flowing from north pole to south pole. When and a strong magnetic field it should be there, then that magnet shows more magnetic flux lines around itself. And when the magnetic field of that magnet should be lower one, then that magnet is having lower magnetic flux lines. Now, as we know, the magnetic properties should be having two types of forces, that is nothing but attraction type of force and repulsion type of force. Now, the attraction and repulsion type of a force is to be introduced along with the poles which are placed near to each other according to our applications. Now, if we can connect or we can place the two same poles between a smaller distance between them, then and a repulsion force is to be introduced by that magnet, and it is indicated in first diagram of this slide. That should be nothing but figure number A. When an magnet having the poles of S and N and another magnet having the poles of N and S are kept together, then two similar poles are available near to each other. Now in this situation, the repulsive type of a force is introduced among these two magnets, and hence force exerted on that magnet is having opposite force direction due to that magnetism. Now it not only happens with north pole only, but it also happens with the S pole, and that situation is indicated with B diagram. When N and S magnet, it should be kept near to S and N magnet, then also two similar poles, that is nothing but S in this situation, is kept together, and because of that the same polarity of magnet, it should be introduces the repulsion type of a force between these two, and hence over here the force exerted on two magnets is having the different directions. Due to that, the repulsion type of a force is introduced when A and B situation will be there. Now in the third diagram, that is N and S, it should be kept to another N and S pole of the magnet, then S pole and N pole, these are different with each other, the different poles of each other, and now according to the magnetism concept, the different poles should be creates the attractive type of a force between the magnets, and it should be indicated with the attraction type of force which are getting closer to that force should be indicated with diagram number C. And when fourth combination should be there, that should be nothing but S and N pole of a magnet, it should be having the another magnet, that is nothing but S and N, then the N pole is nearly closer to the S pole, and because of two opposite poles are kept together, then the attraction type of force is to be created between these two magnets, and hence the force produced by that two magnet, it should be attracted towards each other. Now from this diagram we can take an conclusion that when the two magnets having the same poles near to each other should be creates a repulsion type of a force, and when two magnets having different type of poles closing to each other, then that magnet should be creates an attraction type of a force. Now in the next slide we can discuss the Bose Magnetron concept. The Niels Bohr is the name of that scientist who has invented the the magnetic moment concept of an magnetic material. Now, according to the Niels Bohr, the magnetic moment due to the spin of an electron is known as Bose Magnetron. It is indicated by capital MB. We have an equation of MB, that is MB is equal to Q into H divided by 4 pi ME. Again we have to be revise this one. MB is equal to Q into H divided by 4 pi ME. When we can put all the values regarding with this equation, we can get the actual value of Bose magneton is equal to 9.274 into 10 raised to minus 24 ampere meter square. Now in this equation, that is nothing but MB is equal to Q into H divided by 4 pi ME. In this equation, small q is the charge which are present on that electron, small h is nothing but the Planck's constant, Me is nothing but mass of an electron, and according to that we have a value of 9.274 into 10 raised to minus 24 ampere meter square. Now the Bose magneton is the most fundamental magnetic moment as per the magnetic material is to be concerned. Bose magneton is the most fundamental magnetic moment is present in the magnetic material. Now the Bose magneton we have discussed in a deep in this diagram. Now in this diagram we have the nucleus present at the center of this circle, where the length L arrow should be introduced. The initial position of that nucleus should be present at the center of this circle, having particular distance of radius r. Of an electron it should be present to the orbit. The electron is having negative charge which are continuously moving around the nucleus with an orbit. The electrons are moving according to a stationary velocity indicated by small v, and when the electron is break down its orbit and moving towards another electrons, for the conduction of flow should be indicated by small I, that is nothing but the current which are introduced by electron. Now the mu is nothing but the permeability. The definition of permeability is that permeability is defined as the ability of a material to easily allow the magnetic lines to pass through it. Permeability is defined as the ability of a material to easily allow the magnetic lines to pass through it. Now the magnetic materials have high permeability, whereas the non-magnetic materials have low permeability, which are denoted by mu. Now over here the mu is directed towards an downward direction, whereas L it should be indicated in upward direction. Okay, now the Bose Magnetron should be introduced is that when an electron is moving around the nucleus in a particularly way, that is in an orbital motion, then the electron also spin around itself having some velocity with a particular direction. Now, according to the orbital motion around the nucleus and the spin around itself should be creates a magnetic moment which should be causes to the magnetism property. It should be introduced by Bose magnetron. Okay, so this is how the magnetism concept has been introduced. Again, we have to be discuss the same concept for the better understanding. When an electron is having the spin around itself in anticlockwise direction, then the permeability it should be creates and downward direction itself. And when the electron speeds in clockwise direction, then the permeability of that magnetic material should be indicated by mu m is having an upward direction. The electrons present in that orbit should be moving around the nucleus as well as the electrons are spin around itself, and according to that the magnetic moment is to be present in that material. Now in the figure number B, the nucleus should be indicated with a black circular spot. The dotted line is nothing but the path where electrons are moving around the nucleus, and according to that in anticlockwise direction the permeability produced by that magnetic material should be introduced or indicated in a downward direction. Now according to the Bose magnetron concept, the electrons which are moving around the nucleus is having the property of spin of electron around itself in ascending with the nucleus should be creates a magnetic moment, and the net magnetic moment should be introduced by magnetic material with the help of magnetism. The number of flux lines should be created by magnetic moment is depends upon the electron spin magnetic moment and the nucleus which are attached to that electron should be present in that atom. Now the question is that why not all materials are magnets? If the magnetron concept is available in each material, each magnetic material, then why not all materials are magnets? Okay, as every material consists the spinning of electrons, each of them couldn't could be a magnet, fortunately, but this is not so because there are two main reasons for it. The first one is according to the Pauli exclusion rule, two electrons with the same energy level must have the opposite spins with each other. Thus, so are their magnetic moments which are cancel out each other. Means what? According to the Pauli exclusion rule, when two electrons having the same energy band with the opposite spin with each other, then the magnetic moment created by that electron is having the value of 0, or the force which are generated in opposite directions, they will be cancelled with each other and the net resultant becomes 0. The second reason is that orbital moments of electrons also cancel with each other, thus no net magnetic moments. So net magnetic moments, if there is no unpaired electrons, becomes 0. The second reason is that the orbital moments of electrons also cancel out each other, and hence the net magnetic moment becomes 0, and that's why the material cannot be identified as a magnet. Now, the some elements such as the transition elements, lanthanides and actinides have the net magnetic moment since some of their energy levels have an unpaired electrons. Some elements such as transition elements, that lanthanides and actinides have net magnetic moments since some of their energy levels have an unpaired electrons. Now, magnetic dipoles. The magnetic dipoles are found to exist in magnetic materials analogous to electric dipoles. A magnetic dipole is a small magnet composed of north and south poles instead of positive and negative changes. When within a magnetic field, the force of field exerts a torque that tends to orient the dipoles with the field. Magnetic forces are generated by moving electrically charged particles. These forces are in addition to any electrostatic forces that may be already exist. It is convenient to think magnetic forces in terms of distributed field, which is represented by imaginary lines. These lines also indicate the direction of the force. Okay, so we have an equation of various parameters. If a magnetic field is generated by passing current I through a coil length of L and the number of turns, that is nothing but N, then the magnetic field strength H it should be integrated by capital H, having the units of ampere per meter, and it is given by H is equal to N L upon L. B sorry H is equal to N into L divided by small l. Now the magnetic flux density, that's nothing but induction, is the measure of lines within a system. It has units per Weber, that is Weber per meter square or Tesla, and is defined as B is equal to mu into H. B is equal to mu into H. Now next one is that in the equation B is equal to mu into H, mu is nothing but the permeability, or it should be also called as it is a specific property of medium and has units as Weber per ampere. The relative magnetic permeability is defined as mu r is a measure of the degree E material can be magnetized, and henceforth mu r is equal to mu divided by mu 0. Mu divided by mu 0. Next one is nothing but the magnetic field. If capital M is the magnetization defined as M, which are defined M is equal to X into M, then B is equal to mu 0 H plus mu 0 M. Again this is equal to magnetization flux density B is equal to mu 0 into H plus mu 0 into M. Again B is equal to mu 0 mu R into H, because Xm is called as the magnetic susceptibility and is given as Xm is equal to mu R minus 1. Xm is equal to mu R minus 1. So this is all about the basic fundamentals of magnetism and magnetic materials. Okay, so if you have any query regarding with this one, kindly message me or reply me with the help of either WhatsApp or after the video watching. Okay, so thank you everyone, thank you so much.